OBS, like you have like these different sources, and you can switch scenes. But with the different sources, you can do stuff like add this like current date and time. And like I'm also screen sharing this one.
Right.
Okay, so what I need you to do is, when I tell you to press enter.
Yep.
But not until I tell you to.
Yep.
And if the robot starts to go crazy and I'm not able to kill it, I need you to run over there and press that button.
The big red one.
Yeah.
Yep. Got it.
Big red one. So this is the best standing policy, I think. Or it's not the best standing policy we've gotten yet. We had one that was more static, but it wasn't resistant to pushes. This policy does like recovery, but it's not able to stand very statically. But yeah, I mean you'll but this is super encouraging. Like I feel fairly confident that I can get walking after seeing this one. Or press whenever you're ready. Enter. And then there's a countdown.
3, 2, 1. That's good. That's good. This is so much better than
It's a lot
before.
more reactive.
Yeah.
The only problem is that it keeps like slipping. And so if you want a robot that's standing, it's like that's not really what you want.
Can your robot just stand still? Can you stand still?
So we've gotten a policy where it will stand still, but it like if it starts to tip over, it just tilts. It's like more or less just freezing the joints in place. But this one actually is meant to be reactive. Actually, if you wanna, can you get your hand to hover over that? I wanted to do this test where I push it, but I haven't done that today. So just get ready.
Yep. That's pretty good. That's pretty good. This is a marked improvement to the show.
Yeah, it's a lot better. I actually had no hopes for this when I saw the policy in Sim today, because you'll notice it like jumps back. And I thought like there's no way it would be able to do that. But like this has been like the best thing deployed so far. Okay. I think I'm gonna cancel it before it messes up something.
Because why? You think errors are accumulating somehow?
No, I'm just like worried.
Why?
I guess we can just leave it running until it kills itself.
Yeah.
But like,
Significant improvement.
yeah, but you can see here, right? So it's actually doing it's receiving a lot of faults.
Where are the faults from?
It's saying here overload fault. I'm assuming it's because one of the motors is overloaded, which could be because like.
Yeah. What are the enhancements doing?
So the policies we train now, it controls all the joints. So this is just what it learns in sync to help balance maybe. But it's pretty cool.
Excellent. Yeah. This is like light years better than the house.
Well, it doesn't. So I haven't deployed a walking policy yet, so I don't actually know. And I've been a little unsuccessful with it. And I think this is like a good stress test to see how long it can last.
In theory, this should last forever, right?
In theory, yeah. But like, if you want to check stuff like maybe maybe some joints get looser, it's good to identify. Like how long is the battery life really?
Yeah.
So you want to know what so back during the AI Open event or whatever, we were using a different simulator, right? So since then we've rewritten the simulator,
Right.
or sorry, rewritten the like training framework, KSIM, which has been a lot of work. This library.
Yeah, I'm sure.
Uh,
It's interesting to see it like go from a stable point to
Yeah, because it's like, if it feels like it's unstable, like it'll obviously try and preemptively correct itself, right?
right.
Um,
So how are you training the model again?
well, actually, it's super simple. It's a one-line file, or sorry, one-file training environment. I can take you through it. So I don't know if you know that we released like our training framework like publicly a few days ago, maybe or last week. Like it was part of the information article push. But we released this thing called KSIM Gym, which is like a very simple launching point for people to train robots with our library. Yeah, but so I'm working on a separate repo called, or it's this joystick example, KBot joystick, and so the fundamental idea is that for every task you do, you want to just be like this single file basically. It's like a very clean repository. So the structure is like, you just very simple. You have a train script and a convert script. Train actually trains your policy. Converts it to our Arcane file, which is like a fully like packaged like model file that we just pass into our deployment code, and it'll know how to format the inputs and everything correctly. And it makes it super easy because the whole idea was we want people to train their own policies with our KSIM Gym as an example. They can send those policies to us, and then we don't need to write specialized code for it. We just pass the file into our deployment code. And because the file contains like all the necessary information about how to format your input vectors and all that, like it'll just massively speed up like this deployment process.
So you basically want other people to train for you.
Yeah, it was the idea.
Yeah.
So far, it's been a little less of that.
Well, it's only been out there for like 2 days, right?
No, like a couple weeks now.
Yeah. I guess a leaderboard too about people who are submitting.
In progress.
Yeah.
It's yet to be revealed.
It's on the leaderboard. I like it.
Yeah. So very exciting. I'm a little worried about how it's bunching up like that. But I wonder
if the torsion from the strings from the rope is causing it to like shit around.
Well, they should be able to compensate for that. Like, okay, you wanted to see the training code, right?
Yeah.
So this is the actual code. This is the code that was used to train this current policy. So the basic idea is every file you have your model definition, right? So the actual model that's running on that is defined here. Our actor class is an RNN, which is like pretty straightforward. Like this is standard ML stuff. And so with like our reinforcement learning setup, you have like an actor and a critic.
Okay.
The actor is the thing that actually determines the actions to take. The critic is meant to sort of evaluate the value of those actions.
Okay.
And so basically the actor is optimizing to maximize value from the critic.
Right.
Is sort of the idea. And the reason why you want a critic is because it smooths out your observation. Because like you can compute rewards, like literally summing up all the terms, but like that's a lot noisier. And also we want to do this thing where it's like you're accounting for future rewards as well, right? Like this state, like at time t, we know that the episode maybe terminates at time t plus 10, but how are you supposed to account for like how important was this state in getting to
Yeah.
some final
Yeah.
award?
Yeah.
So the critic is just like this is another neural net that helps approximate
Got
this.
it. Makes sense.
And so our task definition is pretty simple. It's actually, KSIM is so clean. It's just looking at other like code bases. This one is so much simpler to get started with. It's like so
Good.
easy to build on. It's like very understandable and very modular. So like the idea with
That's a good selling point, by the way.
yeah, the idea with KSIM, we have like this base reinforcement learning class. And then this PPO task, which is the type of optimization, proximal policy optimization, is the actual algorithm we're using. It builds on top of that task, and like it has like these methods, like get these variables that are used for this algorithm.
Yeah.
And then when you like update your model, this PPO task overrides the base class because PPO has its own way of updating the model. And then in my train script, my humanoid, this should really be called standing task, builds on top of the PPO task, right? Because it's using PPO, which uses RL.
Okay.
And the way that, because everything's composable, you can preserve like anything you don't want to rewrite again. Like just, you don't have to rewrite everything. Like you just override whatever functions you need to override. So like with our task, the robot model, like the actual CAD model itself, gets converted to some like file that we need to feed into the policy so it can like simulate the robot. So this is the getter for it. Like you give it, like you load in this, it's called the Majoko model. Majoko is the simulator we use. You load in the Majoko model. Like I'm also doing some stuff here where I override the geom priority of the floor. And this is because like in contacts,
Okay.
it'll take the parameters of the geom with higher priority. So I'm messing around with like the parameters of the floor, so I want to give it the highest priority so that all contacts with it is like, let's use the floor parameters.
Right. Okay.
But this is kind of getting to like very, very deep in the
Nothing more
weeds,
than-
yeah. But like the main important things, you have like physics randomizers. So on every reset, we randomize some aspect of the physics. So like with the floor, we randomize the floor friction coefficient, right? And that's good because you want the policy to learn like what if it's really slippery or what if it's really grippy.
Got it.
We also do stuff like changing the mass of every single link. And this just helps to like sort of regularize the policy as well.
I got it.
You have your events, so like a push event is a literal like linear push or angular push, and you have a jump event which causes it to like jump up a little. And this is all just like you want your robot to be resistant to pushes, which we kind of demonstrated earlier. And then resets, like all this stuff. Like the basic flow of the training cycle, imagine you have your policy, your actor network, right? At every time, we like collect some number of time steps across some number of parallel environments. So let's say we have 2048 environments. That's 2048 individual robots with their, just
Randomized environment.
with randomized environments, whatever. We're using the same actor policy at every time step throughout that trajectory to say, hey, these are our inputs. What are our outputs? Those outputs like control the robot in each of those environments, and you just step through from time 0 to like time 100.
I got it. Okay. This is your test rig. Basically. This is your software test rig. You're like, or yeah, you're training rig. Okay.
Yeah.
Yeah, I get it. That's pretty cool.
Yeah.
And you're
yeah.
limited to 20 tests just because of compute? You're limited to 20 tests just because of compute?
Or I'm using 4096.
Okay.
But yeah, on a 4090, which has 24 gigs of RAM, you have to use 148, I think. So I mean, there are a few factors that affect it. The amount of like how much RAM your training loop takes up. For this stuff, it's due to the number of parallel environments, number of time steps, and batch size possibly, and also size of your network.
getting nervous. I feel like we should turn this off now.
I do want to see how long this can run. Like this is a good stress test. Good stress test. Wow, it's been going for a while. A lot of it. Yeah.
Is there anything unique about this camera that
This one?
yeah?
No, just USB camera.
Mm.
It's actually quite low resolution.
Yeah.
I don't know if like you can tell, but yeah. But it's like sufficient for just recording the tests. Let's see how much battery there is left.
Hmm.
86%.
That's the Chinese interface to the motors. This is
Oh, Chinese interface to the battery.
to the battery.
Don't get it mixed up. Yeah, so it dropped like 4% in I guess 15 minutes.
That's pretty. That's not bad.
But this is not a measure of like battery life. This is a measure of the actual voltage in the cells.
Yeah. Okay.
So the actual voltage dropped by 4%.
That's pretty fast then.
Yeah. So realistically, like the battery life might be
An hour.
maybe 30 minutes.
Yeah.
Which actually is not bad because in the Unitree or in the humanoid marathon in Beijing, like I think the Unitree robot, which did the half marathon in like 3 hours, needed around 3 battery swaps. So actually, I guess you do want to push for an hour to be sort of
Mm.
where the current state is at.
Yeah.
Yeah.
Yeah, this is huge progress. Absolutely huge.
I mean, it has been 3 months.
Has it been 3 months ago?
Roundabout. Okay, probably this test is okay to kill.
That's pretty good. That's pretty good. That's pretty impressive.